percent composition, empirical and molecular formulas, and determining an empirical formula from a chemical reaction data. So we're going to start out with percent composition. If you were in class with us when we covered this first part, then you can skip ahead a little bit, but I'm going to go ahead and cover it again for those of you who are absent. So percent composition, any percentage that we look at is really a relatively simple concept. It's part of something out of the whole thing. And then to make it a percentage, we multiply by 100. So it's really a fraction multiplied by 100 gives us a percentage. So composition is what something is made of. So percent composition is a comparison between the total mass of an element and the mass of a compound. So if we are looking at a compound like this Al2O3, the aluminum oxide, we need to find the element's percent composition. So we'd find the percent composition of aluminum in this chemical. Now the way we do that is based off of mass. So sometimes it's also called mass percent of a chemical. And the way we do that is the total mass of that element, so the total mass of aluminum in this compound, divided by the mass of the entire compound. The place we're going to get these masses from is our periodic table. So as an example, we'll take a look at this one. First thing to do is to find the molar mass of this chemical. So we've got aluminum and oxygen. We've got 2 aluminum atoms, 3 oxygen. We want to multiply by their molar masses. Aluminum is 26.98 grams per mole, and oxygen is 16.00. So we can go ahead and multiply those values out. We end up with 53.96 and 48.00. To find our total molar mass, we just add them together, and we should get 101.96 grams per mole. So that gives us our total. That's going to be our value that goes on the bottom. So now we're going to take a look at finding the percent composition of aluminum. So for aluminum, we want to take aluminum's mass in the compound. So aluminum's total mass, we've already calculated here conveniently. And the total mass of the compound, 101.96. Sorry for the disturbance.
Jacoby Eddington, come to the front of the school.
Alright, sorry for that disturbance. So we can set up our fraction, moles of aluminum over total moles, and we're going to multiply by 100. Our units here will cancel each other, so we can get rid of those, and then we can calculate our answer. So you can take a second and try calculating. You should have gotten 52.92%. And I always label it with the chemical at the end so we know that we're talking about aluminum. Now we would do the same idea for oxygen. So we know oxygen's mass is 48.00, again, grams per mole. I don't mind too much personally if you leave the units off of this part. We know they're going to cancel, but it is a good habit to stay in to write your units out. We're going to multiply by 100, and we end up with 47.08% oxygen. So what this means is that if you were handed any sample of aluminum oxide, Al2O3, you could predict that 52.92% of the mass of that chemical is made of aluminum, and 47.08% of the mass is made of oxygen. So it's something we can use to actually help us figure out chemical formulas. So this is how percent composition is calculated. A lot of times we use percent composition to go backwards to actually determine the chemical formula. So that's actually what we're going to do next.